Hi, welcome to my video on graphing by Vertex Part 2, or graphing the absolute value function. Graph each using vertex and slope. Let's do some examples. The equation y equals the absolute value of x minus 1. Subtract 2. The vertex is the opposite of negative 1, which is 1, negative 2. The slope is the a value, and the a here is 1, so the slope is 1, which is rise over 1 is 1 over 1. So the x and y values, we take the vertex, 1, negative 1, put the vertex in the middle of the table. So we'll take, that's a 1, so we take two numbers on the right, which is 2 and 3. We take two numbers on the left, which is 0 and negative 1. So let's put a 2 in. 2 minus 1 is 1. Absolute value of 1 is 1. So 1 minus 2 is negative 1. So that means 0 should give me a negative 1 because it's symmetrical. Let me explain. Put a 0 in. 0 minus 1 is negative 1. Absolute value of negative 1 is 1. 1 minus 2 is negative 2. Put a 3 in. 3 minus 1 is 2. Absolute value of 2 is 2. 2 minus 2 is 0. So that means negative 1 should give me a 0. Let's try. Negative 1 minus 1 is negative 2. Absolute value of negative 2 is 2. 2 minus 2 is 0. And let's plot those. Let's plot the vertex first. 1 is a negative 2. Right there. 2 is negative 1. 2 is negative 1. 3 is 0. 3, 0. Right there. 0, negative 1. X is 0, negative 1. And x is negative 1, y is 0. X is negative 1, y is 0. And we'll use a ruler. Line up the points better. And there we go. So notice that by using the vertex, putting the vertex in the middle, if you pick x is 1, then you pick two numbers to the right and two numbers to the left. And as you move out 1 unit to the right, or you go 1 unit to the left, 1 unit to the right, you get the same y value as you move 1 unit to the left. If you move 2 units to the right, you get the same value as if you move 2 units to the left. And the domain is always belong to the real numbers. X belongs to the real numbers. And the range, well, this is a positive. It's going up, and it's greater than or equal to the y values start at negative 2 and go up. It's the y value of the vertex. Okay, let's do another example. We have the equation negative 3 times the absolute value of x plus 2. The vertex, the opposite of plus 2 is a minus 2. When you put a negative 2 in the equation, that gives you 0, and negative 3 times 0 is 0, so y is 0. There's no number on the end. The slope of the a value is negative 3. That's understood to be negative 3 over 1. And just get back to the slope right here. So if this is your vertex, and the slope is 1, which is 1 over 1, if you went up 1, right 1, up 1, right 1, you plot this set of points. And if you go up 1 to the left 1, up 1 to the left 1, you plot these set of points. Then notice this is the positive slope, that's the negative slope, that's the absolute value. Again, this is a linear on the inside. X minus 1 is a linear. So we have a V shape with a vertex. Okay, let's do a table of values on this graph. Again, we put the vertex in the middle. That's 2, negative 2, 0. Negative 2, 0 is right there. So we'll pick two numbers to the right, which is negative 1 and 0. And we pick two numbers to the left, which is negative 3, negative 4. And so that means whatever value I get for negative 1, I'll get for negative 3. Whatever value I get for 0, I'll get for negative 4. So we only have to work out just half them. So let's put 0 in. 0 minus 2 is 2. Absolute value of 2 is 2. Negative 3 times 2 is negative 6. So that means that's a negative 6. Check it out. Negative 4. Negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. Negative 3 times 2 is perfect. Let's put a negative 1 in. Negative 1 plus 2 is 1. Absolute value of 1 is 1. Negative 3 times 1 is negative 3. So this means this is a negative 3. Again, check. But after a while, you get used to it. You just, if you put negative 6 there, you put negative 6 there if you pick this order. Try negative 3. Negative 3 plus 2 is negative 1. Absolute value of negative 1 is 1. Negative 3 times 1 is negative 3. Perfect. And we put the vertex in. Now we got negative 2, 0. We put negative 1, negative 3 right here. 0 gives me negative 6. X is 0, negative 6. Negative 3 gives me a negative 3. X is negative 3. Give me y is negative 3. X is negative 4. Y is negative 6. 1, 2, 3, 4, 5, 6. That's got a little gone down too far here. So here we are. And I went 1, 2, 3. I should have been there instead of here. So let me correct that so we won't get confused. So you can put here, gone. Use a little whitener, helps out. But anyway, notice vertex is negative 2, 0, and now we have everything lined up. That one. And sometimes you make an error. I make an error at times, but hopefully I'll correct myself. And the same. There they are. Domain is always x belongs to the real number for the absolute value. If you have a linear, x plus 2, degree 1 is a linear, and the range is y. Notice this is going down, so it's less than equal to, and it's less than equal to the y value of the vertex is going down from 0. Okay, and let's do a couple more. Now, practice means, normally when I show you something, now practice, you work them out and graph these correctly. Here we go, using the vertex and the slope. The vertex, opposite of negative 3 is 3. When x is 3, y is 1. And the slope is negative 2, so that's negative 2 over 1. Negative 2 over 1. Oh yes, I just want to go back and look at that other one just for a second. Notice I said the slope was a negative 3, so negative 3 from the vertex is down 3. 1, 2, 3, right 1. And you also go down 3, 1, 2, 3, left 1. So that's the negative slope. That's the positive slope. Positive is the positive slope because you go up to the right. This is the negative slope because you go down to the right. Or you could go, if you want, you notice you can go down. If you go from this point here, you go down to the right. Down is negative, right is plus. If you go from this point to here, you go up and to the left. Up is positive, left is negative. So it depends on your direction. Okay, let's get back to this one. So put the vertex in the middle, 3, 1. So let's see, 3, 1 is right there. Now, take two numbers on the right. So take a 4 and a 5. And take two numbers on the left, which is 2 and 1. Let's put a 5 in the equation. 5 going in the place of x. 5 minus 3 is 2. Absolute value of 2 is 2. Negative 2 times 2 is negative 4. Plus 1 is negative 3. So that means 1 should be a negative 3. Let's put a 4 in. 4 minus 3 is 1. The absolute value of 1 is 1. Negative 2 times 1 is negative 2. Plus 1 is negative 1, negative 1. So, let's check the table out also, because the slope is negative 2, so it's negative 2 over 1. So notice that this is going down because it's negative. So if I take this vertex and use the slope, I should get these points. So let's see. If I go down 1, 2, to the right 1, right there. If I go down 2, 1, 2, to the right 1. So these points should be these right here. Or if I go down 2 to this way, and I go down 2 more, 1, 2. So let's check to see these points. So 5, negative 3. 1, 2, 3, 4, 5. Perfect, negative 3. 4, negative 1. 1, 2, 3, 4, negative 1. 3, 1. X is 3, y is 1. 2, negative 1. X is 2, negative 1. X is 1, negative 3. X is 1, negative 3. Perfect. So because I plotted my table of values, I'm checking with my slope. So you can plot your table of values, you can put your vertex in, and you can check with your slope. Everything goes together, fits together to make sure you're correct. So I'm using the table of values as a way of checking. Really, if I wanted to, I could graph not doing the table of values. Let's have a look at this one. Let's graph with the vertex. So the vertex here is x is as of 3, so that's negative 3, negative 1. The slope, there's a 1 there, so the slope is 1, which is 1 over 1. So let's graph with the vertex and the slope, and then we'll check it with the table of values. So the vertex, x is negative 3, 1, 2, 3, y is negative 1. There's the vertex. So the slope is 1, which is 1 over 1. So up 1, right 1. Up 1, right 1. Up 1, right 1. Now let's go the other way. Up 1, left 1. Up 1, left 1. And that should be, if I had more longer graph, I could plot more points, but this should be okay. So notice here I went up 1, right 1. And this one I went up 1, left 1. Because the two slopes are, one is plus and one is minus. It gives you the V shape. And let's do a table of values. Oh, I forgot to put the domain in. Domain and range. So domain belongs to the real numbers, and the range is going up, so it's greater than or equal to the y value of the vertex going up from the negative 1. And let's do a table of values of x and y just to check. The vertex is in the middle, so negative 3, and the right side is negative 2, negative 1. And on the left side is negative 4, negative 5. So let's put a negative 1 in for x. Negative 1 plus 3 is 2. Absolute value of 2 is 2. 2 minus 1 is 1. So negative 5 is a 1. That's a 1. Negative 2. Negative 2 plus 3 is 1. Absolute value of 1 is 1. 1 minus 1 is 0. So that should be a 0. Okay, let's check the points. Vertex is, let's check this point. Negative 1, 1. X is negative 1, y is 1. Perfect. Negative 2, 0. X is negative 2, y is 0. X is negative 3, y is negative 1. X is negative 3, y is negative 1. X is negative 4, y is 0. Perfect. x is negative 5, y is 1. X is negative 5, y is 1. So graphing it using the slope and the vertex, you can, but the table of values is also a way to do it too, putting the vertex in the middle and working out the other values. So again, the number in the front is the slope. So this one, notice, is opening down. The vertex is the opposite of the x value that's inside the absolute value, keeping the y the same. And that's graphing using the vertex and the slope, or vertex and the table of values. And if you like my video, click the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.